All right, here we are into the first lesson of IM3, Intro to Polynomials. Now this should probably mostly all be a review for you all, but nevertheless, let's give it a shot. What is a polynomial? Well, let's just talk about what it means. Poly means many, and nomial is just a fancy, that's all like Latin for name. But in this situation, it could also mean like a term. And so what this really means is many terms. That's what polynomial, many terms, okay? So these are all polynomials because we have many terms. This is a term, this is a term, this is a term, this is a term. So technical definition of it, a polynomial is the sum of a finite number of terms where each term starts with a coefficient being multiplied by a variable that is raised by a non-negative integer power. Okay, so let's just kind of recap what I mean by all that. There's a lot going on there. So if you look, for example, in my example up here, we have a coefficient of 9, right? Or here's a coefficient of 15, 9 again, 10. These aren't technically coefficients. These here are constants, but we're going to play with those in a second. And it's being raised by a variable. In this situation, the variable is x. In this situation, it's a, and here there isn't a variable, but again, I'm going to explain that in a second. And it's being raised by a non-negative integer power. So these, what do we mean by integers? It's not a fraction, and it's not negative. See how these are all positive exponents here? Now these constants, what's really going on with these constants, it's kind of fun, is you could think of this 9 here. You could think of this as 9 times x to the 0, because anything to the 0 power is just a 1. So this is really just like saying 9 times 1. And so we could still consider this a term of a polynomial because it could be written with these matching variables. Just like here, I could think of this as like a to the 0, or I could think of this as like y to the 0, whatever variable we want it to be. And so there's our technical definition of a polynomial. And then I have some examples of expressions that are not a polynomial. See how we have negative exponents? So that makes this not a polynomial. If I was just looking at these three terms, that would be a polynomial. But because we have this negative one here, it changes things just slightly. Or here I have a fractional exponent, so that's not a polynomial. Okay, so these are not, these are. Some other words that you might want to know. A monomial. Monomial, that's a polynomial with only one term. So if I was to look at any one piece here, like if you go up here, this is a monomial. If I was looking at just this, that'd be a monomial, or that of monomial. Each one of these on their own is a term, and if I was to separate it out, that would just be a monomial. Next up, I have a binomial, and this is a polynomial with exactly, you probably could guess it, 2 terms, right? So here's an idea of something with 2 terms. And so you might see the pattern here. We have a monomial with 1, a binomial with 2, and so next up is a trinomial. And this is a polynomial with exactly 3 terms. And so I didn't really give you an example of that, but let's say I was to just like ignore this last term here. This would be a trinomial right there. Any 3 terms makes a trinomial. Okay, another word you're going to see is the word degree. Degree. Let's talk about this. This is the highest exponent of a given polynomial. So, for example, up here, the highest exponent, we have it, well, we don't have it exactly in order, but the highest exponent here is 7, so we would call this a 7th degree polynomial. The highest one here is 2, so we'd call this a 2nd degree binomial. And this one, the highest degree is 0, so we'd have to, it's really a constant, but we could also call it a 0 degree monomial. So that's what a degree is. It's the highest exponent in a polynomial. And the last special term I want you to learn here is standard form. And this is when a polynomial is written from the highest degree term to the lowest degree term. So if we take this expression up here, it's not all, yeah, we start with the highest, but notice it doesn't go, it should be a 3 here, then 2, then 0. So if we were to reorganize that, like I have here, this is now in standard form, okay? Because it went from the highest degree of 7, then 3, then 2, then 0. And we could say the leading coefficient is this leading coefficient. This coefficient in the front is 10. So lots of vocabulary that you're going to need to know for this whole unit. So wanted to refresh all that with you all. Okay, let's take a look at the next page. All right, so now you're going to be given some problems having to deal with polynomials. Specifically, they're going to be talking about the average rates of change of polynomials. Anytime you see this word average rate of change, that is just a fancy word for, oops, picked the wrong pen, slope. That's all that is. Average rate of change just means slope. And you've probably seen slope written like this. That's kind of how you usually see it in Algebra 1 or IM1, and that's fine. There's nothing wrong with that. But in upper mathematics, we like to use this equation. It's really the exact same thing if you think about it. All f of b means is the y value when you plug in the b for x, and f of a just means the y value when you plug in a for x. So it's really the exact same thing. So I just want you to get used to this equation here. And so we're just gonna find the slope essentially on these 2 points, and they give us the x value. So if we look at example 1, it says given this function f of x, x squared minus 2x minus 1, what is the average rate of change of f over this interval from -2 to 2? Well, you could just make this be your a, this be your b. Let's plug everything in. The first thing you might want to do is just kind of like, here, I'm going to zoom in here. You might want to just go ahead and say, okay, well, let's figure out what f of b is, right? That's what happens when you plug in your b value. Well, in this situation, my b is 2, so I'm going to do 2 squared minus 2, parentheses 2 minus 1. Let's see, that'd give me 4 minus 1. Well, that's just 0 minus 1, so -1. So f of b is -1. Let's also do f of a. So now we're plugging in -2. So -2 parentheses squared minus 2 parentheses -2 minus 1. All right, well, -2 squared, that's like -2 times -2, so that's positive 4. And then I have a -2 times -2, which also turns into a positive, so we're going to say plus 4 and then minus 1. Well, 8 minus 1 is 7, so f of b is 7. Well, now I have all the pieces, so let's just go ahead and plug it into this equation. My average rate of change, or my slope between these 2 points, is f of b, which we know to be -1, minus f of a, which we know to be 7, over b, which we know to be 2, minus a, which we know to be -2. A couple things here. Whenever we have a double negative, it turns into adding, so we're going to just think of that as adding. So -1 and -7 makes -8. 2 plus 2 makes 4. -8 divided by 4 makes -2. So the average rate of change here is -2. Easy peasy. All right. So here's what I want you to do. I want you to pause the video, and I want you to try practice one on your own. Really, it's the same kind of problem. The equation's slightly different, but not that big a deal. Give it a try, and then unpause when you're ready to check your work. Okay, so remember what I did first. First thing I did is found f of b and f of a. For f of b, I got 4. For f of a, I got -4. And then I plugged it into my slope formula, which I still have up here. So I have 4 minus -4, and my b was -1. -1 and a is -5. -1 minus -5. Again, so I get some double negatives, turns into plus, so it turns into 8 over +4. 8 divided by 4 is 2. So this average rate of change is +2. So here it was -2, here it was +2. It's not always going to be 2 or -2. Obviously, it could be any number. It could be a fraction. It could be any of those things. These are just some simple examples to start us off. All right, here's what I want you to do in the summary. I want you to create your own trinomial and then find the average rate of change on that trinomial from 0 to another number of your choosing. So I would let 0 be your a, and then pick some other b, and that's how you're going to do the summary. I'll see you guys on the next video.